Hello, in this tutorial we'll be introducing some of our advanced Lua editor features, including smarter code completion, go-to declaration, and virtual classes, all of which can catch errors at development time before they become bugs at runtime. Unlike more traditional languages such as Java and C++, where all types are explicitly defined, Lua is dynamically typed, which means it is not obvious from just looking at the code what the type of a variable is. This is where our IDE helps you.
Our IDE now automatically detects primitive types, that is, functions, tables, numbers, strings, and booleans, and keeps track of them for you. Let's make a spaceship prototype table with 4 attributes: color, x-coordinate, y-coordinate, and rotation. Notice how the IDE keeps track of these attributes and their types in the Navigator panel. The variable scope is also seen on the Navigator, helping you catch accidental globals easily. It even keeps track of return values and assigns them to any function calls. Notice how the ship variable also has the attributes of the return value. Our IDE also keeps track of where variables were defined, so you can go to the declaration simply by control-clicking on the variable. This even works between files, so if you had a global defined in another file and you wanted to edit it, you can just control-click to go there. Also, if you just click on a variable, the IDE will highlight all usages in the current file.
Variable scope is also taken into consideration, so auto-completion queries will now only give you the most relevant results. Try an auto-completion query before and after a variable was declared, and notice the variable is only listed when it is defined. Autocomplete also takes full advantage of the inferred variable type. For instance, take a look at this options parameter in this function. Notice how we access the keys x, y, color, and rotation. This is automatically reflected in the autocomplete, and a new option is given with all the values expanded out. This is done with no changes to your code whatsoever.
A very useful feature of more strict languages like Java is type safety. What if instead of inputting a number for x in our create spaceship function, we enter a string like this? A Java compiler would catch this error at compile time and prevent a potential bug, but Lua has no such facilities, and this type of error would result in a runtime exception. Our solution to this is virtual classes. Virtual classes are Lua doc style comments that serve 2 purposes. They help improve the readability of your code by specifying what each parameter is. They allow the IDE to become type aware. You can add Lua doc comments to existing functions by typing 3 dashes and hitting return. Then you can define the classes of the parameters. Let's use numbers and strings for now. Once we define the parameter classes, you will notice that there is a warning informing us of a class mismatch.
Suppose we create 2 sounds using the audio library. This will give us 2 audio handle objects. The audio play, pause, or dispose functions can only deal with audio handle objects, and the IDE intelligently updates the autocomplete to ensure that this class constraint is met. Notice how the parameter requiring the audio handle class is automatically filled in, and subsequent autocomplete queries here will display the relevant object types at the top. All the kernel library functions are fully defined this way. If you wanted to define your own virtual classes, you can do so with the class def keyword. Say we wanted to define a new class called ship with the attributes in the ship prototype class. Just add 3 dashes before the variable declaration, use the class def keyword, and add ship class to the return type. If we had a function that had ship class in its parameter, the autocomplete is smart enough to give you a ship variable first on the list.
Sometimes you will want to constrain the parameters to a certain set of values. This can be done using enumerations in other languages, but Lua has no such facility. Although there are libraries that can do this, it would be much nicer if the IDE could keep track of this for us, resulting in improved runtime performance. Take for instance the audio.loadSound function. The directory parameter is constrained to a predefined set of directories: caches, documents, resources, and temp. The autocompletion knows this and will give you the relevant information first. What if we wanted to create our own enumerations? Simply just use the enumeration keyword in any parameter followed by a set of values. For instance, let's constrain colors in this create spaceship function to green, blue, and purple. Not only will the autocomplete give you the relevant enumerations, it will also throw a warning if there is an enumeration mismatch, as will be the case if we try to input red or anything else. Thanks for watching.